One of the important problems that I'm going to say, the problem statement will be like this: two generator rated 200 megawatt and 400 megawatt are operating in parallel. The droop characteristics of their corners are 4% and 5% respectively from no load to full load, and assuming that the generators are operating at 50 Hz on no load, how would a load of 600 megawatt be shared between them? What will be the system frequency at this load? Assume free corner operations. Repeat the problem if both generators have a droop of 4%. Yeah, already is based on the droop characteristics. There is the two generators, rated capacities of 200 megawatts and 400 megawatts are operating in parallel like that they are given. So therefore, unit 1 and 2 we are considering in terms of total capacity, not exactly the output of the machine. So that will be unknown. So for that one, for unit 1, it is under X values. As another end unit of values will also don't know exactly how much it is producing. So total load is sharing under the case of 600 megawatt load is there. For that one, with respect to the unknown values of the x values are subtracted. Because of this unit, so because the sharing of 600 megawatt from the both the units they are specified as a 600, and 600 means x of this value is only subtracted to, then it will use the exact values and remains the x values. So therefore it will be represented as 600 minus x. So solutions for this case is, because the generators are operated means connected in parallel, so they will operate at the same frequency. As you know, the basic phenomenon is basic principle under the steady state load. Now, this cases let the load on generator run in terms of rated capacities of generator 1 200 megawatt capacities is equal to load, how much it is producing exactly we don't know, is the considerations of the x in megawatt. Similarly, for the load on generator 2, it will be 400 megawatt as rated capacity, so it will be in terms of 600 minus of x megawatt portion. So now this case, when the sharing of this particular load, how exactly this frequency levels reductions are going to be takes place or frequency deviations, we need to check it out. There's a formula for this frequency deviations with respect to this unit 1 and 2. It is nothing but a change in frequency by unit 1 will be represented as regulation into frequency by total capacities, whereas the regulations which given in terms of governor actions, there is a 4% and 5%. So that is 4% will be with respect to 100 base values which are taken into the account, means which will come as a zero point zero 0.04 into frequency is 50 hertz is there, and divided by total capacities of the unit one is 200. So and considerations of this one is zero point zero 0.01 values will come. Similarly, for this frequency deviations, will be equivalent with respect to this values. It's dividing of this values and cross multiplying. Okay, this values will be like this, and this to this will be multiplied. So del f is equal to 0.01 x like this. So this will be for unit 2, del f by 600 minus x is equal to regulations 2 into frequency by capacity, whereas regulations values is 5%, 0.05 into 50 frequency hertz is there, and capacity is for this the unit 2 is 400 megawatt they are given. So answers will be 0.00625. It will come. So this will be also in cross multiply 0.0625 with respect to 600 minus 6. So del f is equal to this value is into 600 minus 6 as considerations of the equations 2. Now we need to equate the equations on it because in the LHS side change in frequency is that del f like that. Equate these equations 1 and 2 here. Okay, that is RHS side. Then you'll get the values of x values. So it will comes approximately in terms of 231 megawatt from the generator 1 capacities of the productions for the sharing of the load. At the generator 2 is 600 minus x like that we are consider. So it is total load by with respect to generated capacity of the generator 600 minus 231, which gives the information regarding the 369 megawatt. Now we just observe that the rated capacities of this part for the unit 1 in the given problem its capacity they said that 200 and the unit 2 is 400 megawatt. When calculating its value is increased from 31 megawatt and here below 400 megawatt. So means that generator 1 is increasing values, that is overloaded like that. This is underloaded conditions. Therefore, load on generator 1 is under 231 megawatt and load on generator 2 is 369 megawatt. So that is nothing but an system frequency we need to find. That is standard value is 50. System frequency is equal to standard frequency minus of equations 1, that is rate of change of frequency values change. Or if you are having doubts means formula for this one, actual frequency is equal to del f plus f naught, whereas actual frequency is equal to rate of change of frequency plus the required frequency values what we are supposed to be find. That is nothing but an need to find frequency is equal to actual frequency minus rate of change of frequency values. For actual frequency, they are given 50 hertz. Del f values for the equations 1. Okay, 0.01x. This you need to substitute for f naught values. So here 50 minus 0.01 x is there. So x, how much you got from the calculations is 231 megawatt. Substitute here, we'll get 47.692 hertz. So what is the meaning of this one? The frequency levels what you are getting, that is nothing but an here we will get the negative sign is taken because the generator 1 is overloaded. Because of overloaded condition, the frequency levels need to be decreased for 47.692. That is nothing but an droop characteristics. Okay, so therefore, due to difference in droop characteristics, Governor 1 generator is overloaded and generator 2 is underloaded condition because its capacities of production is 369 megawatt. So underloaded conditions. Case 2, what they are saying is that the regulation is 4% for both the machines. Now for both the machines, the regulation is exactly 4%. In the previous case, they are given 4% and 5%. Now this formula need to be same, but the values are constant. So first case, del f by x is equal to 0.04 into 50 by 200 capacity. Expressions becomes del f is equal to 0.01x. Similar for unit 2, del f by 600 minus x is equal to 0.04 into 50 by 400. So that is something but this values will come. So therefore, we need to find out this. We will get x values as 200 megawatt and second unit is 400 megawatt. Now with respect to rated values, this will be exactly what any cases. Okay, find out the required frequency. We will get frequency levels in terms of 48 hours. Check it out properly. So load on generator 1, load on generator 2 for this case. Okay, this is the case what we are expected as a part of the system is to find out the required frequency levels exactly which had been proceeded. Now, the major important aspects of this two area low frequency control method will be there. Let us say two controlling area, like one power plant in one area and another plant is another area. In between tie-up lines are to be made where some parameters we're supposed to maintain constant values, and we need to find out in each areas the voltage magnitude also as well as the frequency levels which will be tuned. Whenever there is a abnormalities of the powers, the required amount of powers which are to be obtained from the other areas with the merging of standard frequency as well as voltage magnitude. In terms of maintaining the system reliability, the major things, daylight connectivities will also be important. See, under this case, the general expressions derivations part will be there. That will be expressed as the power transported out of the area 1 is given by tie-line powers at this end, where with respect to voltage 1, area 1 as well as area 2, and the system reactance is tie-line connectivity with the phase angles. Okay, delta 1 minus delta 2, not initial values considerations of the equation C. Similarly, where delta 1, delta 2 naught is the power angle of the equivalent machines of the two areas. So, therefore, here once again in terms of an incremental changes of the delta 1 and delta 2, which causes the tie line powers to be exchanged. So, this will be expressed as rate of change of tie line power in per unit. So, tie line connectivities of this one can be represented as this particular equations are going to exchange. So synchronous coefficient is supposed to be represented here. Therefore, incremental power angles are integrals of the incremental frequencies. So these expressions which are to be expressed in terms of integrals of the incremental frequency. So this part change of power with respect to Thailand connectivities with the incremental frequency 2 pi t1 to of integral frequency levels del f1 dt and as well as rate of change of frequency levels are incremental values of this frequency levels from the area 1 to area 2 which are to be represented, and this one once again proceeded as part of the equations or expressions, and this will be continued in the further stage. Substitutions which are to be necessary, just proceed and practice it how the changes are to be made, which are the substitutions are to be taken into the account after this substitutions, Laplace transformations which are to be proceeded. And next part of the systems in terms of this gain of the systems and prime movers connectivities which are to be made. So according to that, general expressions will comes. So study through this one for the entire derivations. Area control errors will becomes for the connectivity of the two areas. That is error checking cases of the feedback systems and like turbine governing mechanisms with the error checking cases of this transfer function are wholly represented of this diagram. So please go through in terms of a general notes. Okay, thank you.